Now let's continue. Construction of a triangle knowing the measure of one angle and the length of its two adjacent sides. Example, construct a triangle EFG such that segment EF equals 5 centimeters, segment EG equals 3.5 centimeters, and angle GEF equals 75 degrees. So here, if you notice, they gave us the measure of one angle and of its two adjacent sides. So also here, the word adjacent has a different meaning. Here, when they gave us the measure of this angle GEF, they gave us the length of its two sides. The two sides of angle GEF are EF and EG. So remark, the two sides of angle GEF are also called its two adjacent angles. The two sides of an angle, we can name them, we can say that they are the two sides adjacent to this angle in a triangle. Now let's watch an animation of how to do this construction. So first we draw a side EF, segment EF, measuring 5 or of length 5 centimeters using our ruler, and we name it EF and we write its length 5 centimeters. Now if I want to draw the segment EG equals 3.5 centimeters, how can I draw it? Do I draw it randomly? No, because I don't know what is the angle formed between EF and EG. So first I need to draw an angle GEF of vertex E measuring 75 degrees. So I place the center of my protractor on EF and I count from the 0 to the right until I reach 75 degrees. But here, since I know that this point will be named, not this point exactly, since I need to find the third vertex here, G, and I know that EG is the second side of this angle GEF, instead of drawing a semiline with a random length, I draw directly EG equals 3.5 centimeters. I count from 0 till 3.5, and I located the point G such that EG equals 3.5 centimeters. And at the same time, when I drew this side EG, I made sure that this angle was equal to 75 degrees. So here, in this construction, I have the measure of one angle and the two sides of this angle. In the end, I just join G to F using my ruler. I join these 2 points and I have now constructed this triangle GEF such that EF equals 5 centimeters, EG equals 3.5 centimeters, and these two segments are in fact the sides of this angle GEF. Now let's reproduce this figure again. So first I draw a segment EF equals 5 centimeters. Then I draw an angle of vertex E. But here, since I don't know where is G, first I draw an angle of vertex E such that this angle equals 75 degrees. But since EG is the second side of this angle, when I draw this side, I only draw it equal to 3.5 centimeters. Then I locate point G. In the end, using my ruler, I join points G and F. So this is how we construct a triangle, knowing the measure of one of its three angles and the length of its two sides, or we can also say the length of its two adjacent sides. Now let's continue with our final method of construction of a triangle knowing the length of its three sides. Example, construct a triangle MNP such that segment NP equals 7 centimeters, segment MP equals 6 centimeters, and segment MN equals 5 centimeters. So here they gave us the length of the three sides of this triangle M and P. So let's watch this animation showing us the steps of construction. So here the two instruments needed are a ruler and a compass. Why do we need a compass? Now we will see why. So first, using our ruler, we draw the first side NP of length 7 centimeters. Then we name it, and P are its extremities. Then we write its length 7 centimeters. Now to draw the second side MP, it starts from P. I don't know where M is. If I bring my ruler and draw this side randomly, for example, let's draw a segment equals to 6 centimeters randomly. Do you think that MN will be equal to 5 centimeters? No, it's in fact 3.2 centimeters. No, it's wrong, because I don't know what's the angle between PN and PM. So that's why I need to use my compass. So how do I use it? First, I bring my compass, I open it equal to MP. I open it 6 centimeters using my ruler. Then I put the needle of my compass on P, because I don't know where M is. Then I draw an arc of center P and radius 6 centimeters. Now I use my compass again to draw MN. How? I open my compass now 5 centimeters, also using my ruler. Then I put my needle on point N here, because M, I don't know where its location yet. I put my needle on N. Then I draw another arc, a second arc of center N and radius 5 centimeters. If these two arcs don't meet, don't intersect, I can extend it again. So I open it again 6 centimeters and I extend this arc. These two arcs will intersect at point M, and I found the third vertex of this triangle. In the end, what I have to do in the end is join point P to M using my ruler, and it will be in fact equal to 6 centimeters, because PM is a radius of this arc, red arc of radius 6 centimeters. Then I join the points M and N, and the MN will be exactly equal to 5 centimeters, because MN is in fact a radius of this second arc of center N and a radius 5 centimeters. And I obtain this triangle MNP such that NP equals 7 centimeters, MP equals 6 centimeters, and MN equals 5 centimeters. Now let's redo these steps again. First, I draw a segment NP equals 7 centimeters using my ruler. Then using my compass, I draw an arc of center P and radius 6 centimeters here of center P. Using my compass, this arc has P as center and 6 centimeters as radius. Next, I need to draw another arc of center N and radius 5 centimeters. So I open my compass 5 centimeters, I put my needle on point N, then I draw the second arc. These two arcs will intersect at point M, the third and last vertex of this triangle. So we name this point M. In the end, using my ruler, I join points M and P, and I write the length of MP 6 centimeters, and I join the points M and N. It will be of length 5 centimeters. So here I cannot use my ruler by itself to draw such a triangle. It's wrong, because I don't know what is the measure of the angles formed by these sides and side NP. So be careful. You only use your ruler and compass to draw a triangle having the length of its 3 sides. So this is the end of this second part. Thank you for watching.